When a schoolboy in the 1960s living in Dzhezkazgan near the Soviet Union's Baikonur Cosmodrome, I became keen on rocket modeling. And soon I realized the fundamentally irremediable deficiencies of the launch vehicle. For example, its efficiency factor is less than 1%, while a contemporary steam engine's efficiency factor is 15%. Notably, each heavy rocket launch makes a hole in the ozone layer of our planet the size of France. The output of jet engines of each heavy rocket is around 100 million horsepower. Just imagine a herd of 100 million horses. And all this power is emitted in an extremely vulnerable ozone layer of the planet as an extremely chemically active flame. This flame has the exhaust velocity of 4 km per second, which is the 5 times the speed of the fastest bullet. And its temperature exceeds 3000 degrees, which is 2 times greater than the melting point of steel. About 100 space shuttle launches per year will lead to complete destruction of the ozone layer of the planet. Therefore, the United States conducted no more than 10 launches each year. Some rocket fuels, as for example heptile in the Russian Proton, are more poisonous than potassium cyanide, while filling off one of these rockets requires about 600 tons of fuel or 600 million grams. This poison, the fuel of just one rocket with a payload capacity of only 6 tons, is enough to kill all the humanity, all 8 billion people. I also realized that a rocket is just a vehicle that will not provide for the creation of the space industry of the future and the salvation of the biosphere from the burden of the technosphere. The biosphere will be inevitably and imminently destroyed by the technosphere, created on the planet and developed by our rapidly growing technocratic civilization. In the future, no one would be able to hide out somewhere on the French Riviera or on the private island in the ocean. Primitive people born in fires in their homes in a cave died from lung cancer at the age of 20. Then they figured out to take their first technologies outside their homes and therefore were able to survive. Now the entire biosphere of the planet is our home. So that we all might survive tomorrow, it will be necessary in the future to remove the environmentally hazardous part of the Earth industry outside of the biosphere, in the near space. Otherwise, we will suffer the fate of the mold in the petri dish, which, having consumed all the limited resources and polluted the limited living space with its waste products, inevitably dies. I once and for all understood this about 50 years ago. We have 2 generations left, i.e. 40 or 50 years to the point of no return, when the end of our civilization will become apparent and palpable by all, including politicians who are actually managing this impending doom process. And it doesn't matter whether they realize it today or not, it will not help matters for us, or rather our posterity. In the late 1960s, while studying at the Tyumen Engineering and Construction Institute, majoring in railway engineering, I was seriously engaged in the analysis of land transport. While doing so, I reasoned as follows: I know nothing about transport, I only know the laws of physics of our real world in which we live, and how could I design an optimal land transport on this basis? I reasoned straightforwardly on the basis of school physics course. For example, I got from Tyumen to Moscow by some transport, by bike, by car, train, plane or rocket. What will be the efficiency of useful transport work? In Tyumen, I was at an altitude of 100 meters above sea level. In Moscow, it is also at the height of 100 meters. So my potential energy as cargo equal to mgh has not changed. In Tyumen, my speed with reference to the Earth's surface was 0, since I was motionless. In Moscow, it was also equal to 0, since after the arrival, for instance, at the airport, I was also motionless. So my kinetic energy as a cargo equal to 1/2 mv squared did not change either. This being said, the transfer of each passenger from Tyumen to Moscow will require a lot of energy, about 100 liters in terms of fuel. That is, the fuel spent will weigh more than the transported cargo, the passenger. From the point of view of physics, the useful transportation work in this case is equal to zero, because after the transportation the energy state of the load has not changed. Therefore, if you divide zero useful work by E energy spent, we shall receive zero. This is the efficiency factor of any land transportation system. It is always equal to zero. And zero, which is obvious, cannot be improved. Then I started to think further on. If zero cannot be improved, then what for was the energy of my relocation on the surface of the Earth wasted? It turns out that all 100% of the energy is spent not on useful work, but on the struggle with the environment and its destruction. That's what we call the ecology. This is manifested in the emission of exhaust gases, noise from the rolling stock movement, vibration of the earth, abrasion of tires, asphalt, rails, crushed stone cushion, and so on. So, in case of land transport, it is necessary to minimize the suppression of the surrounding environment and its destruction. I was above all interested in the high-speed traffic, as we live in a world of increasingly high speeds. But since we do not live on the moon, where there is vacuum, but on Earth, where there is atmosphere, I was interested in aerodynamics, or rather the aerodynamic resistance to high-speed motion. The formula of the aerodynamic drag power happened to be simple. This power is proportional to air density, cross-sectional area of the vehicle body, the so-called midsection, the aerodynamic drag coefficient Cx, and the speed of movement. The speed in this formula is cubed. What does this mean? For example, if we are moving in the car at the speed of 100 km per hour, and the engine spends 20 horsepower on aerodynamics, this is not a lot of energy, about 4 liters of fuel per hour of engine operation. Now let's increase the speed of this very vehicle up to 500 km per hour. Speed is increased by 5 times. We raise 5 to the third power. We get 125 times. This is how much aerodynamic drag power is increased. We multiply 20 horsepower by 125 and get 2500 horsepower, which is the power of 5 tank engines. Such engine will spend on aerodynamics 500 liters of fuel per hour instead of 4 liters at the speed of 100 km per hour. Further research allowed to find solutions that improve high-speed aerodynamics. For example, 7-fold compared to a sports car like the Bugatti Veyron. The Bugatti, considering the spoiler, has CX 0.42, while a high-speed U-Pod on steel wheels has CX 0.06, which is 7 times less. Moreover, the Bugatti carries 2 passengers, while the U-Pod carries 20 people. These results were obtained experimentally during multiple wind tunnel tests and patented. Moreover, half of the improvements were achieved by eliminating the ground effect, because a rail car on steel wheels, which I later called the U-Pod, does not move on a uniform roadbed but on 2 thin string rails. Now I am planning to improve CX by 20% more, down to the value of about 0.05, which is close to the theoretical limit equal to 0.04. If 9/10 of all the energy is spent for the aerodynamics during high-speed motion, where does the remaining 1/10 go? It turns out on the suspension gear of the vehicle relative to the track structure. I had to study and explore different suspension gear systems, magnetic and air cushion, and the traditional wheel, both as a pneumatic tire and a steel wheel. The air cushion turned out to be the most inefficient system. The magnetic cushion is no better. For example, the Trans-Rapid transport system, developed by Siemens and implemented in the only one project, Shanghai Airport, has the overall efficiency factor of magnetic suspension and linear motor falling short of 15%. This means that the efficiency factor of the Trans-Rapid drive system is lower than that of a modern steam engine, a synonym of energy inefficiency. It turned out that the most effective suspension gear system is the steel wheel, steel rail, with the efficiency factor of 99.8%, as a force of about 2 kg can move along a horizontal rail track a bogie weighing 1 ton. Losses here are by an order of magnitude and at high speeds by 2 orders of magnitude, less than those of the system pneumatic tire asphalt concrete roadbed. The Bugatti, for one, at high speed spends on the wheels about 500 horsepower of the engine output, or 100 liters of fuel per hour. If it had steel wheels, it would spend on them only 10 horsepower and 2 liters of fuel per hour. Then I had to improve the very steel wheel. In the U-boat, it is 2 times more effective than the conventional railway wheel pair. Therefore, the Bugatti on our steel wheels would spend only 5 horsepower and 1 liter of fuel per hour to overcome the resistance to wheel rolling. Energy consumption for the motion is the operating costs that must be borne every second, every minute, every hour, every day, every year and every century. For example, the longest in the world is the Russian Trans-Siberian Railway, which is about 10,000 kilometers long. For 105 years on end, trains here have been keeping on in efficiency, spending energy to move billions of tons of cargo for thousands of kilometers, which translates into millions and millions of tons of fuel spent. If you look at aviation, every single A380 Airbus will burn more than 2 million tons of aviation kerosene during its entire service life. There is more than 1,000 railway trains of 40 tank wagons, each wagon filled with 50 tons of fuel. But on top of this, there are capital expenses for the construction of any transport system. Any road can be built in 3 design variants. First, on the Earth's surface, in the Earth bank. Second, underground in a tunnel. Third, above the Earth's surface, as an overpass. The cheapest option, in the Earth bank, is the most environmentally dangerous one. Embankments destroy soil. In today's world, the area of land raised to the ground and buried under railway ties is larger than the territory, for example, of the UK by more than 5 times. This land is dead. It does not grow vegetation that produces oxygen needed for life on the planet, including our breathing. The Earth bank, where the soil is compacted by 10% in comparison with the natural condition, is a low-head dam, which cuts off river sources, the movement of ground and surface waters. This leads to swamping on the side of the Earth bank and desertification on the other. Therefore, we often see dried-up trees and even entire forests of deadwood next to the road. The Earth bank severs the migration routes of animals and interferes with agricultural activities. Underground tunnels are very expensive. Today, building 1 kilometer of transport tunnel costs hundreds of millions of dollars or even $1 billion. A passenger feels uncomfortable in the tunnel. We are not underground inhabitants, and it is dangerous to life too. Studies show that in the Moscow metro, for example, one can be safe only the first 3 seconds. The rest of the time, the station tends to destroy our body. Insulted and compressed space, extreme noise and vibration, strong electromagnetic fields and other unnatural impacts are very harmful to humans. Now we are left with the elevated overpass, but it has a high materials consumption of tens of thousands of tons of steel and concrete per each kilometer of its length, and consequently high cost, $100 million per kilometer and more. However, if we remove the uniform roadbed and leave only narrow strips for the wheels to roll, then we shall lower the price of the span structure by an order of magnitude. And if we make the structure continuous along its length, without expansion joints, we will increase the carrying capacity of the overpass twofold. Besides, to prevent compression and buckling, the truck structure must be stretched in the longitudinal direction. It must be made pre-stressed. It was the origin of the concept of the optimal elevated transport system, later called UST, Unitsky string technologies. Its main elements are: First, continuous, uncut, pre-stressed string rail overpass. Second, rail electric vehicles on steel wheels, U-pods, with exceptionally high aerodynamics. As a socially oriented person, I always wondered what my inventions would bring to humanity, not only now, but in the distant future too. This was how the idea of string rail was formed, which a quarter of a century later was tried out on the test facility in the town of Ozorny in the Moscow region. With the weight of the track structure of a mere 120 kg per linear meter, a 48-long string rail span was twofold more rigid than a conventional permanent bridge. The ZIL 131 truck, weighing 15 tons while moving, caused the track structure to cave in by 30 mm only. It is 1/1600th part of the length of the span, while the permissible relative stiffness of major bridges is 1/800th. And it turned out that when the top of the support is attached to the continuous track structure, the load-bearing capacity of the support increases by 8 times. Therefore, the supports may be dozens of times cheaper, as in addition to it, weight load from a light overpass will be by an order of magnitude less than in conventional girder bridges. Here are some figures. Over the last 100 years, about 60 million kilometers of roads were built globally. They are motor roads and railways. If they are replaced with the UNET transport and communication network, built with the UST technologies, it will bring about the following socio-economic effect for the planet and all humanity. First, thanks to the being on the second level and having the anti-derailment system of rolling stock, the transportation accident rate will decrease by more than 1,000 times. It will be lower than that of aviation now. Over 100 years, this will save from death on the roads at least 100 million people, and from disability at least 1 billion people. It will be more important than ending all wars on the planet, than casualties from terrorism and industrial injuries, than losses from natural disasters like earthquakes, tsunamis and volcanic eruptions taken together, as 3 times fewer people die there, on average about 500,000 people per year, while on the world roads about 1.5 million people are killed annually, including post-accident deaths in hospitals, and over 10 million become disabled and crippled. The car turned out to be much more dangerous than the Kalashnikov assault rifle and the nuclear bomb. Second, owing to the elevated overpass design, the land users will retrieve their territories in total area exceeding 5 territories of Great Britain. As noted earlier, this land is now occupied by roads located on the first level. Simultaneously, 10 times larger area of soil adjacent to such roads will be saved from transport's carcinogenic pollution and environmental degradation. The socio-economic effect of this measure will exceed $100 trillion over 100 years. Third, due to the elevated overpass design, there will be no need to move about 1 trillion cubic meters of soil from quarries to road embankments and cause a huge environmental damage to the nature of the planet. The socio-economic effect on this measure will exceed $100 trillion too. Fourth, due to the low material consumption by string rail overpasses, compared to the conventional transport flyovers, their construction will help saving on steel over 200 billion tons, concrete and reinforced concrete more than 1 trillion tons. This economy is the total manufacture of building materials by the whole Earth's industry over the 100-year period. The socio-economic effect on this measure will exceed $1,000 trillion. Fifth, thanks to the high aerodynamic of the rolling stock and the special steel wheel, the UNET track network will save over 1 trillion tons of standard fuel over a 100-year period, which is, for example, 5 times the world's oil reserves. The socio-economic effect on this measure will also exceed $1,000 trillion. There are also additional advantages of the UST technology on the global UNET track network, whose socio-economic effect over the 100-year period will exceed trillions of dollars. 6. Trillions of tons of atmospheric oxygen will not be additionally burnt in automobile engines and power plant furnaces. 7th. Green plants will additionally produce trillions of tons of oxygen on the fertile soil returned to the biosphere. 8th. Trillions of tons of environmentally hazardous, toxic and carcinogenic fuel combustion products will not be ejected into the atmosphere, soil and water. 9th. The string road network can be easily combined with power and communicational lines embedded in the track structure. Therefore, in the future, all power lines in the entire internet on the planet will be here in the UST. Therefore, the total socio-economic effect from the creation of the global unit track network will exceed $3,000 trillion in the 21st century. This project is vital for our civilization and our planet. I want to invest all my money earned of the UNET technology in the development of the ever more significant space program U-Space. Nobody is ready to finance this program today, neither Russia with its Roscosmos, nor the United States of America with their NASA, nor the United Nations. Interestingly, only research and development work under this Geocosmos program will require more than $100 billion of investments. The basis of this program is not rocket geospace transport along the road Earth-Orbit-Earth, named the General Planetary Vehicle, abbreviated as GPV. This is also string transport. The GPV is capable of delivering up to 10 million tons of cargo and up to 10 million passengers into orbit in one flight. Moreover, it is environmentally friendly, since the GPV is a reversible electrical system. At the same time, the net cost of geospace transportation will be reduced at least 1,000 times in comparison with conventional launch vehicles. The implementation of the U-Space program, the cost of which is estimated at several $1 trillion, will ensure the transition of the Earth civilization to a new development stage. It will become a space civilization, where industry will be removed outside of its home, the planet Earth. Our civilization, and consequently our grandchildren and great-grandchildren, will acquire limitless possibilities for further technological development without conflicts between the terrestrial biosphere created by God and the industrial technosphere created by Homo sapiens. There is another question which has agitated me since childhood. I knew that we were not alone in the universe, and there are civilizations that have overtaken us in their development by millions of years. Why don't they come in contact with us and help us in our development? Now I have the answer to this question. One must not come in contact with savages. What can you discuss with a civilization that is war-torn, brandishing nuclear sticks, and spends trillions of dollars annually just to kill one another? It is us who are not ready to come in contact, not them. However, when the U-Space program is implemented on the planet Earth, we shall become a space civilization. This program can be implemented only by a force of all humanity. For this to happen, all countries will have to stop wars, unite the scientific, economic and production capabilities, and jointly remove into space all the noxious terrestrial industry, metallurgy and chemical production, energy and mining industry, and so on, while living on Earth only fields, forests, meadows, rivers, seas and clean air, along with all the humanity, about 10 billion people by that time. That is when our civilization will be welcomed in the Space Club, and we will be contacted by other civilizations that have passed a similar stage in their technocratic development on their planets.
Anatoli Unitsky, инженер нового мира.